Welcome to the Nelson Lab. This is our synthetic space. Follow me. So, if you're doing synthetic work in the Nelson Lab, we have all of the equipment and all of the know-how. So, every fume hood has its own Schlenk line, no manifold. That makes it easy to run reactions under inert atmosphere, so like polymerizations under argon. And it also makes it easy to pull a vacuum if you need to do a distillation. So every fume hood also has its own vacuum pump that we maintain ourselves. So I just wanted to do a quick demonstration of an ether precipitation, which is a very common technique if you're going to be making polymers. And we'll let that stir for about 15 minutes. Okay, so once you've made a polymer and purified it, then you need to learn how to characterize it. So, let's go learn about characterization.
Thank you, Ryan. Once we have our materials, we have to characterize it. And here in Nelson Lab, we have different characterization instruments. For example, we have the GPC to measure the molecular weight of our polymers. In addition, we have the rheometer to measure the viscosity and also the curing rate of our resins for the SLA printing. Also, we have this extensometer for measuring the mechanical properties of our materials. So now, let's go to the printer room.
Welcome to the printer room. In our lab, we have two types of 3D printing. The first one is wet photo polymerization, and the second one is extrusion-based 3D printing. Let me show you the first one of wet photo polymerization. Right now, I am using the stereolithography or SLA printer, and as you can see here, this printer has the light that can initiate the polymerization, which can adhere to the build plate that can move up and down to build an object layer by layer. This type of printer can give you a complex architecture and a high resolution feature like this.
Extrusion printing. Here is the first extrusion printer in our lab, which is the air-driven or pneumatic printer. As you can see here, here we simply apply air into the syringe loaded with the hydrogel, and the gel extrude directly onto the print bed. So the second extrusion printer we have here is the Hi-Rail, which is a mechanically driven printer. So we use the Hi-Rail for prints of material that require a higher force to extrude, as well as prints that require higher resolution and precision.
Hi everyone, my name is Al-Shakim Nelson, and I hope that you enjoyed your lab visit today. We develop polymeric and biohybrid materials that can be patterned using 3D printing. And we do this with an eye toward developing microbial bioreactors, 3D printed objects that can change shape, biodegradable materials that can be used in medicine or for sustainability purposes as well. So if this piques your interest, we look forward to meeting you during the virtual open house.